Hello everyone, I'm Lynette Schaefer, and in this video, we will compare incandescent halogen and fluorescent and HID light sources and explain how each light source produces light. So as I mentioned in part one, artificial light sources date all the way back to 1879 when Thomas Edison created the first incandescent lamp. Now, of course, additional sources such as mercury vapor and low pressure sodium and fluorescence all kind of made their first appearance in the 1930s. And of course, lighting technologies began to be refined in the 70s and 80s. And then of course, in the 90s is when LEDs actually kind of got to get started. Now, before LEDs were developed, all of the light sources were enclosed or sealed inside some kind of glass envelope, as you can see by the traditional Thomas Edison incandescent lamp. Well, what's interesting is you can see with LEDs, they are not that at all anymore. They are actually very much different from traditional light sources because they are the only one that's not enclosed in some sort of glass envelope, and that makes them a directional light source. So before we get into that, let's take a look at all of these different traditional light sources. So as we look at the different light sources, each one kind of has their own unique advantages. Many incandescent light sources still exist, as do halogens. Of course, fluorescent lighting really took off in the 80s, followed by HID, both of which require a ballast. And what the ballast does is it regulates the current to the lamps and provides sufficient voltage to start the lamp. We'll dig into each one of these sources in just a minute, but first, let me show you how LEDs compare. So right out of the gate, you can see that LEDs come in so many different shapes and sizes. They can replace just about any traditional light source. And some replacement LED lamps have screw-in bases. Some have plug-in bases, just like traditional lamps. And when it comes to LED fixtures, many LED fixtures have the LED light source integrated into the fixture, which means there are no more replacement lamps. Instead, it's just basically a strip with LED chips. Now, all of these LEDs, whether it's a replacement for an incandescent, a halogen, HID, fluorescent, or a brand new fixture, they all have a driver, which is very similar to a ballast. You remember with traditional light sources, the only ones that have a similar thing, which would be a ballast in that case, is fluorescents and HIDs. LEDs, however, they all have a driver. So what makes light sources different from one another? Well, each of them produce light differently, and they also have very different characteristics that set them apart from one another. Now, I remember back in, say, 2010, I suppose, it used to be that customers still had choices in deciding what type of lighting technology they wanted. But nowadays, the price of LEDs have come down so much, and they are so much more efficient and last so much longer than traditional light sources that most lighting projects, whether it's a retrofit or new construction, are all pretty much just all LEDs. But in order to have a true appreciation for LED technology, it's important to understand the evolution of these other light sources. And in order to do that, we have to go back to the incandescent light source. So incandescent lamps have a glass enclosure containing a filament. So when electricity is applied to the lamp, the current passes through the filament, heating it up until it glows. And really the only main difference between an incandescent and a halogen is that instead, a halogen actually has these little atoms inside. And the job of these little halogen atoms is to collect all the tungsten that is emitted by the filament and redeposit it back onto the filament. Now, this, of course, allows halogen lamps to run longer, and it prevents the tungsten from depositing on the glass and darkening the lamp. Now, most halogen lamps are referred to as, say, an MR, like this little guy right here that I'm holding. Some of them are also known as a PAR, which is what you see here on the screen. They basically, the R in both of these situations basically stands for reflector. Now, as you look at these two images, you can see that these halogen lamps are a little slightly different from an incandescent. However, they do make halogen lamps that look like a traditional incandescent Thomas Edison light bulb. But most commonly, they do look something like this, or like this little MR that I'm holding here. Now, back in the day, people liked using incandescents because they were inexpensive. They, of course, have a very high CRI. They come on instantly. They aren't affected by ambient temperature. There's no ballast. They come, of course, in a large variety of shapes and sizes and bases and wattages, and they were pretty easy to dim too. Now, the problem is incandescent lamps are not very efficient. They produce a lot of heat, and they have a very short lamp life as well. So as I mentioned, incandescents and halogen lamps come in many shapes and sizes. So as you can see from this chart, Anytime you're replacing a traditional incandescent or halogen lamp, it's important to ensure the LED lamp will fit into the existing fixture and that the base is also correct. So let's talk about these different lamps and shapes and bases. So the chart on the left shows a number of lamp shapes, not just incandescent. They also include a number of miniature lamps. They range from A lamps to MRs to BRs and Gs and specialty lamps. The chart here on the right shows a number of base types from screw-in to twist lock to plug-in. When we talk about incandescent and halogen lamps, those typically will have a screw-in base or in some cases a twist lock. However, there are a number of halogens that also have a bi-pin base too, kind of like this MR lamp that I'm holding right here. It plugs in, right? So let's talk about the traditional A lamp. An A19 is the standard light bulb in the US in our households, and the letter A or arbitrary refers to the bulb shape. Now, all lamps have a lamp shape. That's why there are so many of them. Additionally, all lamps have a base. The traditional household A lamp has an E26 base. The letter E denotes that the bulb has an Edison, or the lamp has an Edison screw-in base, and the number 26 means it has a diameter of 26 meters. The number 19 designates the size of the lamp, and all lamps are measured in 1/8 of an inch. So let's just review that one more time. So let's take this A17 lamp. Since all lamps are measured in 1/8 of an inch, an A17 lamp is 2 1/8 inches in diameter. How did I get that? You take 17, you divide it by 8. If it was a A19, it would be 19 divided by 8, which is 2.375 inches in diameter. Now remember, it's the diameter, not the circumference. So you measure from the widest part of the lamp. And again, this works on any lamp. So take apart 30, for instance. 30 divided by 8 equals 3.75 inches in diameter. Again, not circumference, but diameter. As we look at bases, all bases are measured in millimeters. So for instance, this little E12 base is just 12 millimeters. And E26 is 26 millimeters. Again, that's diameter, not circumference. It's important to know how to measure lamps, because if you have a customer who's holding a lamp and they don't know what they have, you can always start with the shape, the base, and the size, then work your way from there. Very helpful to know this information. So in this example, this happens to be an R40. It has a reflector shape. R stands for reflector. And if you take 40 divided by 8, you know the diameter is 5 inches. On the other hand, this is a G40. So you know this is a globe shape. G stands for globe. And this is a G40. So you know it is 5 inches in diameter. And you can see here it also has an E26 screw-in base. So that means the base is 26 millimeters in diameter. Now, traditional household incandescent lamps are also referred to as GSL, general surface lamps. Let's try that again. General service lamps, SERVICE, service, not surface, and are used in general lighting applications and account for the majority of installed lighting in residential applications. Now, the DOE, which stands for Department of Energy, in 2022 published an updated definitions rule. And the purpose of it was to basically highlight the fact that GSL doesn't just include traditional A-type lamps anymore. As a matter of fact, it includes a lot of other lamp types, and those other lamp types can include CFLs and LEDs and some halogens, and the list kind of goes on. The main reason for this is because the DOE is all about promoting energy efficiency. What this has done, though, to manufacturers is it's forced manufacturers to stop selling traditional lamps. As a matter of fact, most manufacturers have stopped manufacturing not just the traditional incandescent lamp, but many other CFLs and HIDs and halogens, as well as some miniatures and specialty lamps, and also some circuline fluorescents. So there's been some big changes in 2022, and is going to continue to push more and more people to use LED technology. Now let's move into fluorescent light sources. Now fluorescents work different than incandescent because they create light by sending an electrical charge from one side of the lamp to the other to excite the ionized gas. So you can imagine, you got energy that ignites, the power goes on, you flip the switch, and all of a sudden you have these phosphors running from one to the other. This process is actually kind of cool because it allows you to, have this sort of moment where you have a tremendous amount of light, but unfortunately, well, I should say a tremendous amount of light compared to an incandescent. But the problem is that it contains mercury, right? So a lot of people don't want to use mercury because it can be costly to dispose of it, and you have to be a little bit careful if the lamp breaks as well. But either way, the process actually creates an ultraviolet light. So you got more UV issues too with fluorescent lamps. But the ultraviolet light in the lamps, it's basically got also a coating inside the lamp. It's kind of like a white phosphor, and that helps convert the output to a white light that we're normally used to seeing. Now, let's move into the advantages. So there are many fluorescent lamps still being used today because they are fairly efficient, especially compared to incandescents and halogens. They have a pretty significant and sufficient life rating. They last fairly long. They are available in a variety of color temperatures. It just depends on the phosphor that's used, and that can range from 2700K to 6500K. They do have a decent CRI. They work with many fixtures, and they are also dimmable if you are using the correct dimming ballast. Doesn't just have a standard ballast. So there's actually two different types of ballasts. There is the traditional ballast that does not dim, and then there's another ballast that is dimming, and then there's also a few other types of ballasts that are out there too that help regulate the voltage to the fixtures. Now the problem is that with fluorescents, they require a ballast. That's one problem. Fixtures tend to be larger to accomplish and accommodate the ballast. Of course, the compact fluorescents aren't terrible when you start to compare it to a traditional incandescent, but you can see that ballast here is on the base. So you still have to have a ballast somewhere to be able to regulate the voltage. Now, the other thing about fluorescents is they can be affected by temperature. When with fluorescents, you also do not want to be turning them on and off constantly. The more you turn on a fluorescent and off a fluorescent, the shorter the life will be. I know this from firsthand experience. So if you ever put a sensor on a fluorescent fixture and you don't commission it properly, or you don't set it to the maximum time to time out, and those fixtures or those lamps specifically are turning on and off a lot, those lamps will end their life very, very shortly and very quickly. Now, similar to incandescents, you will also notice that fluorescent lamps come in many different shapes and sizes. Fluorescent shapes include circuline, U-bend, and linear, as well as compact fluorescents. They range in size from 2 foot to 8 foot. They also have many different base types, such as screw-in and plug-in. As you can imagine, the plug-in base types can be a bit of a challenge, as each one of them are slightly different from one another. So if you have a customer using a plug-in style compact fluorescent or linear fluorescent that plugs in, you have to ensure the correct base is specified when replacing the lamp. And this same thing is true if you're replacing those traditional CFLs with LEDs that plug in. So I just want to take a little bit more time to talk about this. So specifically, compact fluorescent plug-in base types can be a little bit more difficult, but there are a few things that can maybe help a little bit. So the first one is which I found this actually pretty interesting. I just learned about this not too long ago. So when you look at these different base types, the 23, the 24, the 7, and the 11 is measured from pin to pin. So if you see 23, that means it is 23 millimeters from one pin to the other. And you can see this here on my example. So a 23 is pin to pin is 23 millimeters. Let's see, G24 means that the pins are 24 millimeters, and a G7 would be, of course, 7 millimeters from pin to pin. Also, the other thing that's interesting is if you see the 1, 2, and 3, this is where the tabs are positioned. So 1 means the tab is on the top and bottom, while the 2 means that they're actually left and right of each other, top and bottom, left and right. And then the 3 is just the exact opposite. Fairly important. Take a picture of this slide because it might come in handy for you sometime. Now, just like incandescents, fluorescent lamps are also measured in 1/8 of an inch. Some are 1.5 inches in diameter, some are 1 inch, some are 5/8 inch in diameter. I have two of them right here. One of them happens to be, of course, 1 inch in diameter. The other one is tiny, it's 5/8 inch in diameter. So when we say, for instance, T5, that means it's 5/8 of an inch in diameter. If it's a T12, it's 1.5 inches in diameter, and a T8 is 1 inch in diameter. 8 divided by 8 is 1 inch. Now, unlike traditional incandescent lamps you may be using in your home, the ones that screw in, linear fluorescent lamps require a lamp holder or something that will hold the lamp into the fixture. Sometimes this is also referred to as tombstones. And basically what that tombstone does is, as I mentioned, holds the lamp in the fixture, but it also is where the power comes from. So you basically have power coming in through the ballast, and from the ballast it comes into those tombstones, and then from the tombstones they go and they energize the base of the lamp. That's how that works. Now, again, these are sometimes called tombstones because they kind of resemble the shape of a tombstone. We don't make it very hard in the lighting industry, do we? All right, moving on. So next we have HID. Now, HID stands for high intensity discharge. There are 3 basic types of HID lamps. There's mercury vapor, high and low pressure sodium, and metal halide. Of these, mercury vapor and low pressure sodium are pretty much gone. Now, all of these operate in the same general principle, but produce dramatically different results. So an HID light is produced directly from the arc itself. Now, due to the high pressure under which these types of lamps operate, the arc becomes extremely intense. So once turned off, it must cool down to reduce the arc to pressure before the arc can restrike. This means that the lights have to have kind of what they refer to as a restrike time, and it can be up to 15 minutes before they actually come back on. So yes, HIDs do have a long life similar to fluorescents, but they traditionally produce way more lumens per watt than fluorescents or incandescents. That's why people like to use them. However, sometimes the form factor can be not very conducive to all applications, especially indoor commercial environments. So HIDs are, smaller form factor versus, like, say, a long 4-foot linear fluorescence. However, HIDs aren't great because of that warm-up time that I was just talking about, or the restrike time too. So initially with HIDs, they have this like warm-up time. And that can take anywhere, like I said, between 10 and 15 minutes. And then, of course, they also have an additional 10 or 15 minutes of a restrike time if power ever gets lost to that particular fixture. So you can imagine when you lose power, say in an industrial application, there could be a major security and safety concerns, and not to mention the downtime and the cost that also is incurred when you have a power outage and you are using HID lamps. Now, the biggest difference between a high pressure sodium and a metal halide is that a high pressure sodium usually gives off a golden yellow light. It also has a very low CRI, and it will turn on and off when it's approaching end of life, which is called cycling. Metal halides, on the other hand, gives off more of a whitish kind of color light. It does have better CRI ratings. And of course, over the years, the improvement to metal halides and high pressure sodiums is that some of them do have the technology, for high pressure sodiums especially, have the technology where it's a non-cycling high pressure sodium. It does cost usually a little bit more for that particular type of lamp, but it does help with that end of life characteristics. Of course, the characteristics of a metal halide, it just basically continues to burn, and it'll start to reduce in light output, lumen output, but it will also start to change color briefly and kind of like a purpley kind of color as well. So at any rate, this is basically the highlight of high intensity discharge lamps. So like other lamp sources we talked about, HID also come in different sizes, different bases. Medium and mogul are the most common. Medium is, of course, that E26 base. That's what we're used to with our traditional A-type lamp that we might use in our home. The E39 is the larger base. We refer to that as a mogul base. And again, E26 means 26 millimeters, right? The diameter is 26 millimeters for the base. And for an E39, you can imagine it's actually bigger. So it's a 39 millimeter in diameter for that base. So as you can see, traditional light sources come in many sizes and shapes. Additionally, different light sources produce light differently. Some light sources are more efficient than others. Some light sources require a ballast to regulate the voltage. And of course, different light sources last longer than others as well. As a matter of fact, speaking of life ratings and how long they last, life ratings are different from one traditional light source to another. Now, traditional light sources will burn out. They will burn out, okay? Unlike LEDs. Now, the life ratings for a traditional light source are based on average rated life or rated hours, which means 50% of the lumens will burn out prior to the manufacturer's published average rated life. So there are different characteristics of end of life and different light sources. If you ever need to know what the average rated life is of traditional light sources, just go to the spec sheet. It'll say 1,000 hours. And of course, if it says 1,000, then you know at 50%, or at 1,000 hours, 50% of those lamps will be burned out. Now, let's talk about signs of end of life. There are some things that you can help kind of go over with your customer. So the first one is incandescent and halogens actually don't have a significant sign of end of life. What happens is that the filament will get weak and then it'll break and then the lamp fails. So if you ever have an incandescent lamp and you're like, I don't know if it works, just look inside there. If you see a break, that means it's not going to work. The other thing about incandescents is they don't like vibration. So a lot of times back in the day, we would put incandescent lamps on, say, a piece of equipment. Well, that vibration, or even in an elevator, that vibration can cause the filament to break, and that also reduces the life very quickly. The next one is fluorescent. All right, fluorescents, they do actually have a little bit of a noticeable end of life. And besides the fact that they'll lose about 5% lumens from the day that they started or that they were installed, you'll also see darkening ends, black ends. That's a pretty good sign too that they're about to fail. Metal halide end of life is caused by sodium loss from the arc tube. And what will happen is the lamp, one, will have a harder time starting, and it may also start giving off a blue or kind of pink color. And the other thing about metal halides is it will have a noticeably lower lumen output from day one, about 40% as a matter of fact. Now, high pressure sodiums will do something that I referred to earlier. It's called cycling. When they get close to going out, one day the lamp will be turned on, and then the next day it will be out. Then the next day it'll turn back on. Kind of a maintenance nightmare because it's really hard to troubleshoot when you're not out there and know exactly what lamp is having that problem. Now, high pressure sodiums also lose light as they age. Not quite as bad as metal halides, but they still lose about 15% lumen output. So speaking of lumen output, we refer to this actually when lamps lose lumens, we call it lumen depreciation. Now, nearly all lamps, including LEDs, have some kind of lumen depreciation, which basically just means that the light source ages. As it ages, it produces a much lower light than it did on day one. So as we just mentioned, fluorescents lose about 5%, metal halides about 40%, and high pressure sodiums about 15%. LEDs lose a substantial amount, but it just takes longer for that process to happen. And you're going to hear about that in a different training video. Anyways, something else that contributes to a loss of lumens on the work surface is luminaire dirt depreciation. That means that the fixture and the lamps get dirty and the light just can't penetrate through the dust and the dirt. As a matter of fact, let's just say that you have a customer that installs, say, a 6-lamp T8 linear high bay. Say they put a lens on it and it's an industrial application. According to the spec sheet, those lamps were rated for 2,850 lumens. You multiply that by 6, that means it should have been producing 17,100 lumens. However, all those lumens never actually made it to the work surface where the task is actually being performed because, one, the lamp itself is giving light off in a 360-degree pattern beam spread. So a lot of that light is getting trapped up inside the fixture. Also, some of the lumens can't make their way through the lens because, of course, the lens is kind of blocking some of that light to get down on the ground as well. That we refer to as lumen dirt depreciation and lamp lumen depreciation. Now, the other things to take into mind is something called equipment factors, like extreme heat that can cause the lumens to decrease, heat extraction, which basically means that the fixture and material used may not be suitable for the environment. Perhaps the customer has voltage changes throughout the day. Maybe they just don't have clean power. Maybe the ballast or the lamps aren't working together like they should. Perhaps the environment is causing some of the components within the lamp. Maybe it's really high temperature or really low temperature. Maybe the ballast and the fixture, aren't sized properly for one another, or there was a mistake or something like that. Maybe there's a wiring issue. All of those things can lead to additional light loss factors, which we refer to as these ATF, HE, VE, BF, and CD as equipment factors. Now, once you've taken all of this into consideration, it could be very well off that this fixture that we used in my example, the 6-lamp T8, when you look at it, those 17,100 lumens, after you take all these things into consideration, it could just be that only half of those lumens, 17,100, are actually hitting the ground and going to where it needs to go, which is pretty crazy. That is the downfall of having a traditional light source be an omnidirectional light source, because you're losing a lot of that light. And of course, it's also trying to get through lenses and all this other stuff. So just kind of keep in mind that when we have a fixture that has 17,100 lumens and it's a traditional fixture, not all of those lumens are getting onto the work surface. So far we have covered traditional light sources, including incandescents, halogen, linear, compact fluorescence, metal halides, and high pressure sodiums, and of course also mercury vapor. Now, these technologies have been around for a very long time, and nearly all of them have been replaced with LEDs. A driving factor is that LEDs have come down drastically in price from just a few years ago. They are definitely more efficient than any of these other light sources. But also, don't forget that the DOE, Department of Energy, is also making us manufacturers produce more LEDs that are more energy efficient, that are more economically feasible, and they are pushing for traditional light sources to go away. Thank you. And if you would like a course completion certificate, please email me, and keep in mind there are 2 N's in Lynette. Thanks again.